Hello everyone, you're welcome to my YouTube channel. Alright, here is another Olympiad Math problem which is asking us to evaluate this particular expression. And so what are we going to do now? Of course, if you look carefully, you will see that this is simply a problem from the concept of the square root of Surds. So you recall that I have a video or some videos on this channel which I'm going to add the links to some of those videos at the description of this video. All right, so you may want to check it. So what do we do here? So we want to recall that if I have x plus maybe root y, and then I am taking the square root of this. So what we would usually do is that we will say that we should maybe equate this to, and then we will then ask that the square root here should go to the other side, and then when it does, it becomes a square, and then we will simplify to get our solution. Now that's a long approach to use. Meanwhile, there is also another method which we can apply. Okay, so it says that if I'm able to express this in such a way that it is of this form, where is of this form a plus b, and then I now have plus 2 into the square root of ab, then in that case is simply equal to the square root of a plus the square root of b. Okay, I will try to use an example to explain what we are saying. Okay, so if we are asked to get the square root of, let's say, 8 plus say 2 root 15, for instance. So you would see that, of course, we can actually express this in such a way that this is equal to 5 plus, of course, 8 is equal to 5 plus 3, and then I can write this way, where this is square root of 5 multiplied by 3. So can you see what we are saying? So if we can express whatever you have in such a way that it can become a sum, that's the part which is not the real part can become a sum of two numbers, and then there is a 2 multiplying the square root, and the square root also has a product of the same two numbers that were originally summed outside, then the answer to this is simply the square root of 5 and then plus the square root of 3, and that's just your answer. So now there is this method. Now this actually lies on a particular principle, and that's just the principle of expansion. Of course, you know, if I have a plus b all squared, this is equal to a squared plus b squared plus 2ab. So if you recall, if you open up these brackets, you will get this. So in other words, it means that if I have the square root of 5 plus the square root of 3 all squared, this is simply equal to the square root of 5 all squared plus the square root of 3 all squared, then plus 2 times the square root of 5 times the square root of 3. Of course, this is going to give us 5 plus 3 plus 2. Root 5 times root 3 is root 15. And of course, you get back your 8 plus 2 root 15. All right. So you see that this has given us where we started originally. All right. So that's actually the principle. And if it happens that you would not remember this, now this is another approach to go about this particular method I just showed, the second method I showed us now, and that is you are given 8 plus 2 root 15. So all I would want to do is to see a way where I can split this root into 2, and the simplest thing to do is to split it into root 5 times root 3. And when I do, remember that there is 2 here, and when I do that, I will ask myself, what is the square of root 5. That is simply 5. And then I'll add it to the square of 3, and that will give me 3. So if I do the square of this and this and the sum doesn't give me 8, then I would need to simplify again and look for ways to get that. But in this case, it immediately gives us that. So that is to say then that what I have is going to be the square root of 5 all squared plus the square root of 3 all squared. And then when you now apply this principle I just used here, you are now moving from this direction to this direction. So that means this is now going to give me root of 5 plus root of 3 all squared. And remember, you are taking the square root of this. So when you now take the square root, this will cancel this, and then your answer will now be root 5 plus the root of 3. Okay, so that's how to go about it if remembering this formula will be a problem. Meanwhile, the approach we just used now is not really what I wanted us to use. Now let's see the next method I want us to use, because if we continue doing this, in some of the problems it may not be effective in helping us do it faster. So let's look at the next thing I wanted us to use. Now there is another method that is going to also help us. That method says that if I have the square root of x plus the root of y, that this is simply, I'm just going to write the formula. We will not be able to show the proof of that formula in this video, but of course just take note of it. We will use some examples to show it before solving this. Okay, so this is going to be equal to the square root of x. Now you close this. Plus, now since this is plus, this place is going to be plus. If here was minus, this place will be minus also. You are basically repeating the same term or the same statement, only that the second one will now have a minus, but the first one here will be plus. Okay, so with this, you are able to get the square root. So let's quickly use that same example we used previously. That's 8, the square root of 8 plus 2 root 15. Okay, so what are we going to do? First of all, we will try to, you can see that in this example or in this term here, we only have a single surd. So we make this to become a single surd. So, and that is equal to the square root of 8 plus, if that 2 comes inside, you will get the square root of 60, because the 2 will become 4. 4 times 15 is 60. So let's try to use that this particular formula to see if we'll get the same thing. So we are going to have this, our x here is 8 and our y is 60. So we'll have 8 plus the square root of 8 squared, which is 64, minus 8 all over 2, then minus the square root of 8 again. In this case, it will be minus the square root of the same 64 minus 8. Sorry, minus, here our y is 60, not 8, okay? So it should be 60 and 60 also, okay? Everything also over 2. So you see what will happen. We will then have square root of 64 minus 60 is 4, and the square root of 4 is 8. Sorry, is 2. 2 plus 8 will give us 10. 10 all over, and that is, sorry, in this case it's actually plus, because what we have here is addition. Sorry, it's not minus. So this is where we should have minus. So we now have plus the square root of, in this case, here is also 4. Square root of 4 is 2. 8 minus 2 is 6 all over 2. And so you will see that we are going to get the square root of 10 over 2 is 5, plus the square root of 6 over 2 is 3. And that's exactly the same thing we got here when we used all of these methods. So that's a better approach to use, and a much faster method to actually get the square root of surds. If you can always remember this formula, and of course it is easy to remember. So that's what we are going to apply now in solving for the other this particular evaluation we are asked to do. I'm going to remove this. Okay, so we'll begin that from the innermost square root we have, which is the square root of 13 plus the square root of 48. So in this case here, our x is 13, our y is 48. So we are going to have, remember the formula, so it's the square root of x, which is 13, plus the square root of the square of 13, which is 169, minus 48, all over 2, then plus, since we have addition here, and then we'll now add the square root of the same 13, in this case minus the square root of the same 169 minus 48, all over 2 also. So here we are going to have the square root of 169 minus 48 will give us 121, and the square root of 121 is 11. So we'll have 13 plus 11, which is 24, and that is over 2. Then we have plus the square root of 13 minus 11, which is 2 over 2. Okay, so from here we are going to get the square root of 12 plus 1. That is the whole of this. So in other words, if we bring that here, we are then going to have that the whole of this will now be square root of 6 plus 2 into the square root of 5. Now here we now have minus the whole of this square root. We got it to be square root of 12 plus 1. All right. So here we are then going to have the square root of 6 plus 2 into the square. If you open this bracket, you are going to have 5 minus 1, which is 4, then minus the square root of 12. Okay, so we are now going to try to evaluate this one. Now, if I may, let me remove here. Okay, so now using the same method, we are now going to simplify this other square root, and that is going to give us the square root of 4 minus square root of 12. Okay, now remember I said when it is minus, then this place will be minus. Okay, so that's going to give us the square root of our x is 4, remember that, and our y is 12. Square root of 4 plus the square root of square of 4 is 16, minus our y, which is 12. You can close here, all over 2. Then because we have minus there, so we'll put minus here, and that is 4 minus the square root of 16 minus 12. And if we close here, we'll have also over 2, and that's going to give us square root of 16 minus 12 is 4, square root of 4 is 2, 4 plus 2 is 6, so we'll have 6 over 2, and that is minus the square root of 4 minus 2, which is 2 over 2. So we are still going to get the square root of 3 minus 1. Okay, so at this point, so we have gotten the value of this, and so we now have square root of 6 plus 2 into the bracket of root 3 minus 1. Okay, so now we can close here, and that's going to give us the square root of 6. If we open that bracket, 2 times root 3 is 2 root 3, 2 times minus 1 is minus 2. And so we will have that this is equal to the square root of 6 minus 2 is 4. And so we now have plus 2 root 3. So quickly, let's take in that 2 into the square root. If we do that, that's 4 times 3, which is root 12. Okay, so this is the last thing we need to evaluate, and we can quickly do that here. So for 4 plus root 12, we are taking the square root. Our x here is 4, our y is still 12. So if we equate, we have square root of x, which is 4, plus the square root of the square root of 4 squared, which is 16, minus your y, which is 12, all over 2, and then this is, since here is plus, so we will add. If we do that, we will have plus the square root of x, 4, minus the square root of 16 minus 12, all over 2 as well. And so this is going to give us the square root of, this is 2 plus 4, which is 6 over 2, and that is plus 4 minus 2, which is still 2 over 2. And if you simplify all of this, you will finally have the root of 3 plus 1 as the solution to this problem. All right, and that is what I have for us in this video. Okay, so you can choose which one you want to use. If you use this approach here, the one I did here, you will also get your answer. It will only take a little time. All right, so kindly subscribe to our YouTube channel. Do give a thumbs up to this video, and we will see you in our next video. Bye.